can you repeat the process? See if you can find the formula. All right, we're gonna give this a shot. The first thing I want you to do is go ahead on the 1.4 set. I want you to pause the video, and I want you to read the paragraph right here. Pay attention to the bullet point. So go ahead, pause me, read that, and then come back. All right, you should have read it, paying special attention to the bullet point right here where it says they've always arranged the fence with one length on one side and 7 pieces on the other. So that should give you an idea kind of how they're doing this, where they're saying this is 1 and 7. All right. If we go to a vertical, this would be 7 and 1. And I focus on that because this is not 1 foot of fencing and that's not 7 feet of fencing. If you look at the table, this 1 length is equivalent to 10 feet. This 7 is equivalent to 70 feet. So they're kind of toggling back and forth. They're using a unit to represent 10 feet. 7 units would be 70 feet. All in all, we still end up with 160 square feet. If you count all the sides, 7 and 7 is 14, plus 1 plus 15, plus another one would be 16. So the total perimeter would be 160 feet. Well, if I change that 10 feet to 20 feet, the 70 feet drops down to 60 feet, still a perimeter of 160, but you get 1,200 square feet. And likewise, I do the same with the 30 feet. If I extend that 20 feet to 30 feet, the width becomes 50 feet, okay? So the width ends up shrinking. Still a perimeter of 160, but a total square foot of 1,500. Pause and go ahead and fill in the rest of the table, and then come back, and we will continue. All right, so what do you notice about the table? All right, now that you come back, you filled out the table. Where is the maximum square footage? The maximum square footage is 1,600, but where is that at? That is at 40 and 40. That is a square. Is it always a square? Well, yeah, it is actually, right? Because the square is a rectangle. So imagine this squeezing together and getting a square. That would be 4 units by 4 units. That would provide the maximum area. All right, so and that is question 6. Discuss Adam's findings and explain how you would arrange the sections so that you would be able to do less work. Well, Adam will ... Pause it and finish that sentence. I'm going to be looking for that sentence to be complete when I grade your work. If I don't see a complete sentence, you're going to get dock points. So pause it and do the best you can to write a complete sentence. Now, coming back, it says, hey, well, 7 says we need to draw the graph for it. Well, first of all, what type of function is it? How do I tell from a table what type of function it is? Well, let's just look at first and second differences here, and let's not look at 7 to 1,200 as hundreds of feet. Let's look at it as units. 7 to 12 is plus 5. We know that's 500 feet. 12 to 5 is plus 3. We know that's 300 feet. And then we go plus 1, right? And then we go minus 1, minus 3, minus 5. Okay, these are all feet and hundreds. Okay, now what's the second difference? Because the first difference isn't the same. So this should be minus 2, minus 2, minus 2, oh, hey, look, it's all minus 2, right? It's all minus 2. So that proves it's quadratic. So my graph should be a curve. All right, so let's make a graph of the investigation. We're going to need to toggle back and forth between the graph and between the table, keeping in mind that this far left column is going to be my x's. And now what are we comparing? Are we comparing length to width or length to perimeter? I doubt length to perimeter. We're comparing length to area. So these are going to be my x's and my y's. So keep that in mind as you fill in. This comes down here as length. Now we're going to do something kind of not ingenious, but we're going to do something here that's going to be, try and make it a little easier. Length in tens, so that I can skip a line and go 1, skip a line and go 2, skip a line in 3, skip a line in 4, skip a line in 5, skip a line in 6, skip a line in 7. And this is actually 10, 20, 30, 40, 50, 60, 70 feet. Not 1 foot, 2 foot, 3 foot. All right? Now the y-axis is going to be area, but area in what? Well, if you go back and look at the table, should we do area in ones, tens? How should we do it? We should do area in hundreds. Okay, so this is in tens, this is in hundreds. It's important to label our graph that way. So I'm going to do this by 1, 2, 3, 4, 5. I'm going to put a 5, but that 5 is going to represent 500. 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. I'm going to do a 10, but that 10 is going to represent what? It should represent 1,000. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I don't need to go to 20. Really, all I need to go to is 16 for the graph, because now I'm going to fill in the table. So label, so all the points on the table are shown provided. Okay, so we have 1 in 700. So 5, 6, 7. There's 1 in 700. We have 2 in 1200. 10, 11, 12. We have 3 in 1500. And we have 4 in 1600. So there is half of my graph. Now, I'm going to show you how to do the other half. I'm not going to plot the points for the other half. I'm going to show you something a little bit different. Remember this dashed line that we draw down here, this imaginary line? What do we call it? If you don't remember what you call that, oops, that's not on 4. Skip the line, gotta go back. Gotta do it right, Mr. Wilson. This imaginary line, as I'm fixing this, by the way, this imaginary line is called the axis of symmetry. The axis of symmetry divides your parabola in half. And it divides it in half equally. So as half of the parabola is drawn, I should be able to mirror the other half. Now, how am I going to do that? I'm going to do that easy. It's simple. That first point that I plotted, how far is that first point from my axis of symmetry? Count up. Count up how far it is. Did you count it? Or are you waiting for me to do it? Don't be lazy, count it. 6 units. So if it's 6 units to the left, I'm going to go 1, 2, 3, 4, 5, 6, 6 units to the right, and there's another point. That point there is on the opposite side. They're symmetrical. How about the second point? Try the second point and the third point that you plotted and see what those are. Pause it, I dare you. Pause it and come back. So what you should get is you should get 4 units and you should get 2 units. And likewise, you should just be able to plot 2 other points. Now, it's not so bad with this table because there's only, you're talking 3 points I'd have to go graph. I'd have to graph 5, 6, and 7. But what if you get a graph with like thousands of points? What I'm going to do is I'm going to pick like 3 random points, plot those, and then mirror that over on the other side, and it makes it real easy for me to finish graphing my parabola right here. Just gives me something to go on. Okay? So there's that. We've done a table, we've done an equation, we've done second differences. We know that it's a parabola because it's U-shaped. So describe the shape of your graph. Some people say a curve, okay? And I'm going to say parabola, because that's what it's called. We'll talk about a parabola. Explain what makes the function quadratic. Well, from the table, we're going to talk about a table, a graph, and an equation, because we did a table first. From the table, what makes it a quadratic? Second difference. From a graph, what makes it quadratic? The fact that it's a parabola, right? Now, from an equation, well, hey, we haven't written the equation yet. So, all right, so here's number 10. And this is what you should be able to do on your own. Remember back when we did the models, right? And we looked at something like this, and then it was 2 by 2, and then it was, I think there was one more, and then we had these here, and then it went 3 by 3, and so on. We had stuff that looked like this, okay? What did we do? Well, we noticed here that these were always the add. So whatever happened to my formula, okay, whatever happened to my formula, at the end it was always plus 2. So then we went back and we said, hey, what is going on here? What do I notice is happening here? We built, in other words, we built models, okay, of the first 2 or 3 patterns to try and come up with the rest of our equation. That's what we did, right? So this is no different. So I want to build a model. Well, we kind of sort of have done one of them already, so it's a little bit of a repeat. If we go back, look at the first model that we built already. But I'm gonna change that just a little bit, because how did we get the 7? That's what I want to know. So here's my first model. My first model is going to be 1 by 7. We know that. But why is it 1 by 7? Well, gee, if I take 1 unit of fencing and put 1 unit on one side, there's 1 unit on the other. That leaves me with 14 units, or 140 feet of fencing left, right? To divide equally. Well, half of 14 is 7, so that's kind of how I did that. Or I could do it this way. I could take this rectangle and I can cut it in half diagonally. That leaves me half of the total amount of fencing for the top and half for the bottom. So what is 160 divided by 2? That is equal to 80. So it leaves me with 80 feet of fencing for the top and the bottom. Well, if that leaves me with 80 feet or 8 units of fencing, one of those 8 units is already spoken for. So how do I find the rest of the units? Wouldn't that be 80 minus 1? That would give me 70 or 7, depending on how you look at it, right? If we did 10, then it would be 80 minus 10. All right, so there's the first model. How about the second model? What if I increased it to 2 units? Now I'm going to do this in units, not in feet. If this was 2 units, how would I stress this other side? It would still be 80, not 80, sorry. I told you I was going to do it in units. It would be 8 minus 2, which would be 6. So 2 by 6. Now, what if I increase that to 3? Well, gee, you should kind of start to see what's happening here. I'm taking the units and I'm subtracting the total for the half. So this 1 represents figure number 1, the 2 represents figure number 2, the 3 represents figure number 3, and so on and so on. So now when I want to come up with my model A of x, how do I do so? Well, I want to do it for any given figure. So I ran out of room, so I'm going to have to just draw this down here, and then I'll have to erase it in a second. But for any given figure x, how do I find this top piece, okay? Or the width, because this is the length. If you look at it, go back in the table, this is the length. How do I find the width? You have 3 examples right here. It's 8 minus x. Or, if we transition this to feet, x number of feet, 80 minus x. So my length is x. How do I find area? Length times width, or 80 minus x. There is your formula. It's exactly what we did with all the other patterns. So now we have an equation. How do I know from an equation that this is a quadratic function? Well, think about it. How do you know from an equation that it's a quadratic function? It's got to have an x squared, right? So has x squared. And you're looking at this going, Mr. Wilson, it doesn't have an x squared. Sure it does. If I distribute. Remember, this is my thought process right here. He's showing some sort of thinking. X times 80, 80x. X times negative x minus x. And then the last thing here is evaluate the equation for the area with a side length of 25. Okay, so what happens if A is 25? If A is 25, you're going to plug 25 into x in your formula. So this is 25 times 80 minus 25, which is going to be what? That's going to be 25 times, what's 80 minus 25? Well, gee, if you don't know, you do some little scratch work over here. 80 minus 25, you got to borrow. 10 minus 5 is 5, 7, 6, 5. That becomes 55. If my length is 25, my width is 55. Now, they're dealing in partial numbers. We only dealt with whole units. But could they break up a 1 unit piece of fence into a half a unit? Sure, they could. They could if they wanted to. Go ahead and calculate out what that square footage is, and then also do A of 65. And you should get those answers as well. So 65 minus 80 minus 65, and figure out what that is, and get your square footage there as well. Question number 12 I'm not going to do. All right, so there is your, sorry for the long video, but I wanted to cover the whole entire set. Ask questions as you need to.